A mass of one slug, when attached to a spring, stretches it 2 feet and then comes to rest in the equilibrium position. Starting at t equal to 0, an external force equal to 8 sine 4t is applied to the system. Find the equation of motion if the surrounding medium offers a damping force numerically equal to 8 times the instantaneous velocity. Now this is the differential equation we wish to use. We need to find m, beta and k. Now m is 1 from here. To find k, we need to remember that mg is equal to ks at equilibrium, and so 1 multiplied by 32 is equals to k multiplied by the stretch, which is 2 feet, and so we obtain k equals to 16. Now this of course is beta, and now we plug this into our differential equation, and we first solve the homogeneous system by obtaining the auxiliary equation m square plus 8m plus 16 is equals to m plus 4 squared equals to 0, and so m is equals to minus 4 minus 4. These are repeated roots, and so xc is c1 e to the power minus 4t plus c2t multiplied by e to the power minus 4t. Now to determine xp, we have xp is equals to a cos 4t plus b sine 4t, and it must take the same form as the input function. Now xp prime is minus 4 a sine 4t plus 4 b cos 4t, and xp double prime is minus 16a cos 4t minus 16b sine 4t. Now I'm going to take out the minus 16, and I get a cos 4t plus b sine 4t within brackets. And now we are going to substitute this into the differential equation, and so we get minus 16a cos 4t plus b sine 4t plus 8 multiplied by minus 4a sine 4t plus 4b cos 4t plus 16 multiplied by a cos 4t plus b sine 4t. And you see straight away that these two terms cancel out each other, and we get minus 32a sine 4t plus 32b cos 4t, and this is equal to the input function 8 sine 4t. And now we compare coefficients, and we get minus 32a is equals to 8, and so a is equals to minus 1 over 4, b of course is equals to 0, and so xp is equals to minus 1 over 4 cos 4t. And when we put this together, we get xt is xc plus xp c1 e to the power minus 4t plus c2t e to the power minus 4t plus minus 1 over 4 cos 4t. Now the initial conditions are x0 equals to 0 and x prime 0 is equal to 0. You can try and substitute these into the equation, and you will obtain that c1 is 1 over 4 and c2 is 1, and so we obtain our final answer as 1 over 4 e to the power minus 4t plus t e to the power minus 4t minus 1 over 4 cos 4t. Now you can check this out for yourself. Now if we try and draw a graph of this equation, we will obtain something like this, where the first part of the graph looks a little strange. Now this is because the first part of the graph is influenced by the transient solution, whereas The second part of the graph here is called the steady state solution. Now if you look at the equation again, you will notice that this part of the solution will disappear as t becomes larger and larger, and so this is the transient part of the solution, and this is the steady state part of the solution. Once the transient part of the solution disappears, the system is governed by the steady state solution.